The question says sketch a position time graph for a bear starting 1.2 meters from a reference point, walking slowly away at a constant velocity for 3.0 seconds, stopping for 5.0 seconds, backing up at half the speed for 2.0 seconds, and finally stopping. All right, so I'll start by drawing some axes. I'll label the horizontal axis as time and the vertical axis as position. They want us to draw a position time graph. For the direction, doesn't really say, so I'll just make the direction forward. Now it says that the bear starts 1.2 meters away from the reference. So I'm going to mark a point 1.2 meters, and that'll be the starting point of the bear. And then it walks at a constant velocity for 3.0 seconds. So 1, 2, 3.0, I'll label that. And it says it's walking away from the reference. So I've got to go away from 0. It doesn't say how fast. I can kind of make that up on my own, I guess. It doesn't really say how fast. So I'll just draw a straight segment, because a straight segment represents a constant velocity. Then it says it stops for 5 seconds. 1, 2, 3, 4, 5. That'll bring us to 8.0 seconds. And at rest means we're going to have no change in position. So this is going to remain at the same position. It's going to be a horizontal line. Try to make that a bit straighter. Okay, horizontal line. And then finally it says it backs up at half the speed for 2 seconds. 1, 2, that'll bring us to 10.0 seconds. So half the speed means that the slope has to be half as much as the original slope. So whatever I had as the slope here, I'm going to now have to try to draw half the slope. So I guess to be as accurate as possible, I can do some calculations. So what value did the bear get up to at that position? Let's just, for ease of calculation, I'll do something that's divisible by 3. So maybe I'll say 3.0 meters. That way, when I calculate the slope of the first segment, which I've highlighted yellow, the slope of that is rise over run. Which gives a rise, since I made the values 1.2 and 3.0, well, 1.2 was given, I made the second value 3.0. The rise is 1.8 meters forwards, and the run is 3.0 seconds. So dividing that gives 0.60 meters per second forward. Therefore, the slope of my final segment has to be half of that, because the question wants the bear to back up at half the speed. And it must be negative because it's backing up, it's going backwards. So negative 0.30 meters per second forward. So if that's supposed to last for 2 seconds, negative 0.30 has to be the rise over the run for my final segment. But my run is 2 seconds. So what's the rise? You multiply both sides by 2, I'll get negative 0.60 as the rise. So my point, which is at 3.0 to begin with, must drop down by negative 0.6. Maybe I'll make 0.6 increments all the way through. That's kind of how I chose my numbers here. So it's going to drop down from 3.0 to 2.4. And that'll get the job done. So your answer might be different in terms of the values you use. You have to have the 1.2 value there. That's what the textbook says, but the other values, how high it goes up to, that was your choice. I chose mine to go up to 3.0.